Now, let's have a look at the graph y equals 1 over x. This one is a little bit weird. Does anybody know what this one looks like? Has anybody drawn it?
Which one?
The y equals 1 over x, number 5. Sorry, number 10. Anybody know what the graph 1 over x looks like? Okay. Well, look, I'm going to show you another technique for drawing graphs if you don't know what they currently look like. Okay? And it's very simple. We just simply draw a table of values, like I did it here. If you're not sure what a graph looks like, just draw a table of values until you get the idea, and then hopefully you can draw it from there. Is that okay? So let's give this a go. So let's do y, let's do x. So can you draw a table of values for the graph y equals 1 over x for me? Okay. So I would start off by maybe putting in some values of x. Let's go from negative 4 to 4. Like so. Could you fill in the y's for me? Okay. And do them as decimals as well to get the idea. Okay, so what are the values of y which we got here? So when x equals negative 4, what's the value of y?
1 over negative 4.
As a decimal?
0.25.
Good. What about negative 3? Vatican, what do we get? So if x equals negative 3, what should y equal? Negative? Negative 2? Negative? Negative 1? Good. I'm going to skip 0 for the time being. What about y? What about if x equals 1?
1.
2? 3? 4? Now I skip 0. Did anybody actually type this in a calculator? Good. Anybody type this in a calculator? So if you type 0 in a calculator, so 1 over 0, what do you get? What do you get? You definitely get something. What does it return you?
Error.
Yeah, it returns you a maths error. Now, I wonder why. I wonder if you can think why. Why should, if we stick x equals 0 in here, why should the calculator go, I don't know what to do here?
You can't divide a number by nothing.
Why? So why can't you do 1 divided by 0? Why can't you divide a number by 0?
Because you're literally dividing it by nothing. There's nothing to divide by.
Okay, so you're basically saying you have 1 chocolate bar and you don't divide it amongst anybody. How much does each person get? That statement doesn't make sense, okay? Can anybody else give me any other reasons why they think 1 divided by 0 gives you a maths error on a calculator? Okay, what does division actually do? What does division actually do? So if I say to you 6 divided by 2, what am I literally doing there? What's division? Start with 6 objects, let's say 6 pens. I haven't quite got 6 here, but let's imagine there were 6 here. Okay, and I'm dividing them into 2 equal parts. So each part has 3, okay? Now if you think about this, so 1 divided by 0, what I'm literally doing here is I'm starting off with one object. Starting off with one object. And what I'm trying to do is split that into no parts. In other words, I'm saying how many times does 0 fit inside this box, okay? Well, if I fill this box with nothing, I can go in once, I can go in twice, I can go in 3 times, it's still an empty box. In fact, so you're happy that I can go in as many times as I like, okay? So one way that you could define 1 divided by 0 is as infinity, because I can fill this box as many times as I like with nothing, okay? In fact, I could also fill it in the opposite direction as well, with negative things, okay? So to be true, I should put plus or minus infinity there, because that's also holding. But are you happy? This basically represents that I'm filling this box here, which is worth 1, with nothing. I can do that as many times as I like. Okay? So that's the reason why it doesn't really have a meaning. Okay? 1 divided by 0 doesn't come out as a number, it comes out as a concept. Does that make sense? Yeah? So I need to think about this. I'm actually going to put plus or minus infinity in here, okay? But it is undefined as a true kind of mathematical concept, okay? It doesn't give me a number. So I need to think about what's happening here. Would you be happy that as I move across from -4 to -1, so from -4 to -1, what's happening in my y direction? Am I growing? Am I getting negative, bigger? What's happening here?
The number is decreasing.
Good, so it's getting bigger in the negative direction. Would you be happy with that? Because from -0.25 to -0.33, that's only a change of like 0.1. But from -0.33 to -0.5, that's a change of like 0.2. And then from -0.5 to -1, that's a change of 0.5. So it's definitely growing, but it's growing in the negative direction, and it's not growing by a linear amount. Now it needs to tend towards negative infinity. That's what's going on at 0. So would you be happy that on the left-hand side, as I move from left to right, this thing is growing in the negative direction? Okay. Now, it can never ever reach plus or minus infinity. Like, that doesn't make sense on this line. So all we say is it gets closer and closer and closer to this axis, but it never ever reaches it. Okay? All right, okay, let's think about what happens as I move from 1 to 4 then. So I'm on this side now, 1 to 4. What's happening to the y's? It's decreasing, right? And again, it's not in a linear amount. So would you be happy you get a graph that looks something like this? Okay. Now I should add something to this graph as well, and I'm going to put it in red. I'm going to put a set of dotted lines down the y-axis. Okay. The reason why I do that is because it tends towards plus or minus infinity. So in this direction, it tends towards negative infinity. In this direction, it tends towards positive infinity. Okay. Does anybody know what we call that line there?
What line?
The dotted line, the red dotted line. Begins with an A. Good. The asymptote. Okay. Now, all an asymptote is, and we will meet asymptotes again. Okay, so it's worthwhile introducing it now. An asymptote is just a line that the graph tends towards, but it never ever reaches. Like, it gets infinitesimally close, like it gets dangerously close, but it never ever reaches it. It's kind of quite sad. Okay. Now, technically, there is another graph. There is another asymptote on here, and it's that one there. Okay, which is the x-axis. Because again, this thing will get infinitesimally close to the x-axis, but it will never ever reach it. Now actually there are asymptotes on these graphs as well. Okay? Asymptote on this graph would again be the y-axis, and the asymptote on this graph would be the x-axis for y equals 3 to the power of x. Okay? So we always put the asymptotes in dotted lines. Okay? So in this case the asymptote would be y equals 0 and x equals 0.